Okay, let's take a look at the summer assignment. So a lot of the questions in the summer assignment, well, not a lot of them, some of the questions in the summer assignment are asking you to see what you can transition from Math 7 to your Math 8 curriculum, kind of merging the two, and see what you can recall and how you can manipulate expressions. It also is seeing whether you're familiar with some other topics. So some of these topics you're actually going to study in depth in geometry, but some of them are simply just to see if you know it. All right, so taking a look at number 3. So 3 is an interesting problem. It's asking you to simplify this expression. So I have x plus 1 minus 2 times x plus 5 over 3 minus x plus 6 over x minus 1, right? And so the idea is really that you want to find a common denominator. Essentially, these are fractional components, and in order to simplify this, we're going to have to kind of give them all the same common denominator and combine our numerators. Okay, so how are we going to do that? Well, if it was just these two terms, my common denominator would simply be 3. But because I'm throwing in this expression, my common denominator is actually 3 times x minus 1. So that's kind of interesting. All right, so I'm going to go through each one of these fractions, and my goal is to make the denominator 3 parentheses x minus 1. Okay, so on the first one, it doesn't have a 3, and it doesn't have an x minus 1, so I'm going to have to multiply both the numerator and the denominator by that LCD. Now in the second term, I already have the 3, so now I'm going to multiply the numerator and denominator by an x minus 1. And then finally, in this last expression, I already have an x minus 1, so I'm going to multiply the top and bottom by the value 3. Okay, so the idea behind that word simplify is really just to get a common denominator. Okay, all right, so now we're going to have a little bit of algebra here. I'm multiplying x minus 1 times x plus 1. I'm going to have to distribute the x to both terms, and I'm going to have to distribute the negative 1 to both terms. And then after that, I'm going to have to multiply by the number 3. So I have 3 parentheses x squared plus x minus 1. Over here, I'm going to maintain this negative, but I'm going to put a bracket around the term. So I have 2x plus 5 times x minus 1. Again, I'm distributing, so I have 2x squared minus 2x plus 5x minus 5. Again, here I'm going to keep this negative, and I'm going to distribute the 3 into both of these terms. So I have 3x plus 18. And then essentially all of these terms are going to have the same common denominator. 3x minus 1, 3x minus 1, 3x minus 1. Follow me so far? All right, so now I'm going to distribute my values that are in front of my brackets and combine at the same time. So I'm going to try to do both of these in one step. So here, if I'm combining like terms, I have an x and a negative x. These two terms should eliminate, and I'm going to distribute the 3. So I have 3x squared minus 3. Over here, I have a negative 2x and a 5x. This should make a 3x. So I have a negative 2x squared. Notice this is now a positive 3x, a negative 3x, and a positive 5. And then over here, I have a negative 3x and a negative 18. Now remember, when we're adding fractions with like denominators, I maintain the denominator and I simply add the numerator. So 1 plus 5 is 6, and I'm maintaining the denominator of 12. That's what we're going to be doing down here. I'm going to combine these numerators and maintain the denominator. So I'm just going to collect some like terms before I write that denominator. I have 3x squared minus 2x squared is 1x squared. And then over here I have, let's cross these terms out because we're combining them. Now in the x's I have a minus 6x. And I'm going to cross those out just so I don't forget about that. A negative 3 and a positive 5 is a positive 2. And then 2 minus 18 is a negative 16. And all of that is going to be over my common denominator of 3 parentheses x minus 1. All right, so that is the idea on number 3A. I would encourage you to try 3B. My hint on that is you have a single term, give that a denominator of 1, and then we have 20x minus 4 over 5, and then we have a minus 2x squared over 3. Look at your denominators. What would be your LCD? So your LCD would be 15, no? So the idea is you want to multiply this expression by 15 over 15, this expression to make it into a 15 by 3 over 3, and this expression by 5 over 5. All right, so that's the idea behind number 3, and then you can check your answer once you try that. 7 is actually not as terrible as it looks. This is actually a combined math 6 and a combined math 7. So you're using proportional techniques to be able, math 6 and math 8 and algebra 1. So you have x minus 1 over 4 and a 3 times an x plus 3. So you're using proportions to be able to figure out the value of x. And if you recall, when you have proportions, you can use the strategy of cross multiplication. So I can multiply x minus 1 times x plus 3, x minus 1 times x plus 3, and then 4 times 3 is equal to 12. All right, that's how cross multiplying works. Now I'm going to distribute this. X times x is x squared. X times 3 is 3x, a negative 1x, and a negative 3. And now we have 3x minus x is 2x. So I have x squared plus 2x minus 3 equaling 12. And now my goal in this problem is to solve for the value of x. So I'm going to set it equal to 0 and use factoring strategies to solve. So let's see, we got x squared plus 2x minus 15 equaling 0. Factors of 15 that are going to make 2 are going to be a 5 and a 3. So we have x plus 5, x minus 3, and then I have solutions of negative 5 and positive 3. And then I just want to make sure that that seems to work out. 3 plus 3, yeah, that's a half. That's 2, that's a half, and then negative 5. Yeah, all of them seem to be working out. So you have 2 solutions for x, either negative 5 or positive 3. And that's the same idea in letter B. You have 3x over 2 equaling x squared plus 5 over 2x plus 1. You want to cross multiply this, set them equal, and solve. All right? And then the final bit deals with distance formula and midpoint, it seems like. There's a bit about